We are finally ready to start writing our own code.
Woohoo! It's about time.
When we write code, we need a strategy for planning what we write and making sure that what we wrote works. For that, we'll use test-driven development. The philosophy in TDD is that we write tests that will verify that our code works before we write our code.
That seems kind of backwards.
Initially, it does, but there are a lot of benefits to this strategy. By thinking about our tests first, we're essentially thinking about how someone else will use our code. How will they call our methods? And what will they need those methods to accomplish? This means that we build clean interfaces that are easy to use. We also have to think about how we'll know if the method worked. Again, this helps us design interfaces that we can verify to be correct. Another benefit of TDD is that it will help us build our code in little steps. This has two benefits. First, it helps us know that progress is being made. We can see what functionality already works, and that helps us maintain momentum. Second, because we have only a little code since the last time things were working, bugs are pretty easy to find. Finally, using TDD gives us a full suite of tests that verify everything we've built. That means we can make sure that things we add don't break things that used to work, and it gives us confidence to clean up the code. Just like when you write an essay, the first code you write isn't always the prettiest. Since we have a full suite of tests, we can clean things up without worrying about whether we broke something. The tests are our safety net. In addition, the tests describe the way we think our classes will be used. When someone else needs to use it, they can find the test that verifies the behavior they want to use, and that shows them the way they need to structure their code to get the job done. So now we have two kinds of code, the code in our tests and production code, which is the code in the system we're trying to build.
So we're building twice as much code. This is going to take forever.
You're right that we have to build the tests, but we had to do that anyway. We need to verify that our code works, so the choice is to build the tests first or second. Building them first helps us think about what we're going to build before we dive right into it, and it keeps us from building too much in any step of development. So building the test first leads to better code. In test-driven development, we iterate through three steps. First, we get to red. This means that we write a test and we write just enough code to get it to compile and watch it fail.
Why would you bother watching it fail? You know it should.
Imagine that the test already passed the minute we wrote it. If that was true and we didn't catch it, we could write any code we wanted to make it pass. If we only ran the test after we wrote our code, we'd think that our code made the test pass when it was already passing without any of our code. So the question is, how could the test pass right away? Well, there are two ways. First, we might make a mistake writing the test so that it isn't really testing anything. Second, we might be thinking we need to develop code that has already been written. That second problem sounds pretty ridiculous until you think about big systems with lots of people working on them. If two people both thought that they were responsible for building part of it, one would get there first and build it. When the second got there, their first test would go green because the code is already there. So, we make sure that the test goes red before we write any production code. Once the test is red, we write the simplest code we can do to make the test go green. This lowers our stress. Anytime the tests are red, it feels like something's broken. The faster I get to green, the happier I am. This also means that I want the test to require that I only add a little bit to the system at a time. I want that red window to be as small as possible. Getting to green doesn't mean we have good code. It just means our code works. From there, we refactor. Refactor means clean up the code without changing its behavior. So we stop and look at the code. We want to make sure that it has the necessary comments, that our variables have meaningful names, and that our code doesn't have any duplication. We don't want values hard-coded in our tests or our production code. JUnit is a tool that helps us do TDD. It has two parts. First, it's an extension of Java that lets us easily write tests. Those tests are just methods in special Java classes and use annotations that start with @signs to let JUnit understand how it should run the methods in our test classes. Second, it has an Eclipse plugin that we can use to run our tests and get immediate feedback about whether they passed or how they failed. The plugin has a progress bar that turns green if the tests pass or red if any test fails, so it's easy to see how things are going. Studies have been done that show that being skilled in JUnit actually reduces your coding time, even though you have to build the tests in addition to your production code. Here is the first test class from the lab. It has tests for a class named Book that is keeping track of a book in a library. Let's look at it carefully. It starts with import statements. These are used to help the compiler find classes that we're using. So these statements are helping it find classes that are in the JUnit extension. The rest of the source file specifies a class named TestBook that has one instance variable named book1 and two methods, setup and test initialization. The method named setup is marked with the annotation @before. This tells JUnit to run this method at the beginning of every test. All this method does is create a new book named Catcher in the Rye and stores it in our instance variable. Putting this in an @before method means that every test will get a book that's in its initial state. This is important because JUnit makes no promises about the order in which tests will run. That means that we need each test to be independent.
Saying that the tests are independent means that no test needs any object to have been manipulated by another test. In this case, since every test will start with a brand new object, we know that they can be run in any order.
Right. Thanks for clarifying. Sometimes I forget that I need to define terms like that. Our second method has been marked with the annotation @test. This means that it contains a test. The name of the method is a clue that we're just testing to make sure that the book was created correctly. When this test runs, the first thing that will happen is that the @before method will be run, and book1 will get a new book object. The test method will then run its three statements. The first is a call on assert equals, which takes two parameters, the value that we expect to see, and the call that we expect will return that value. These are called the actual and the expected. This is telling JUnit what we expect, that if we ask a book for its title, it will return the string Catcher in the Rye. If they are not equal, the test will fail and the rest of the method will be skipped. But if they are equal, the test will continue to the next statement. The next statement is a call on assert false. This takes one parameter. If that parameter evaluates to false, the test continues. Otherwise, the test fails right there. This assert is checking that, when we first create a book, it thinks that it is not checked out of the library. The last statement is checking to verify that the newly created book thinks that the number of times it's been checked out of the library is 0. If none of the asserts fail, we'll get to the end of the method and JUnit will say that that test has passed. Let's think about what this tells us about the class we are testing. Its name is book, and we can list the methods that it has to have by looking at the methods the test calls. So a book object needs to answer questions about its title, whether it's currently checked out of the library, and the total number of times that it has been checked out. That tells us three things it needs to know, so those are our instance variables.
She's right about what it looks like, but there was one more clue in there. Get title is checked out, and get number of checkouts are named the way we said we'd name getters. That's another clue, that there are three instance variables, and the return types on those methods tell us what type those variables must be.
So just for thoroughness, I thought I'd take us through the first round of red-green refactor so that you can see how TDD really works. So here are the first round of tests that we just talked about in the PowerPoints. The first thing that I have to do, I've gotten it typed in, but now it's complaining about syntax errors because we haven't done enough code to get this to compile. And to get to red, we need to make this compile and run and get to red. So this is saying we need a class named book. So I'm going to create a new class named book. And when I go back to my tests, that error got fixed. So this one is saying that there is no constructor in the book that has a parameter that is a string. So either we can remove the argument and that would make it the string would go away and then everything would be all right. But we need a constructor where we pass in the title of the book. So I'm going to let it create that constructor of a book. And it gives the thing a stupid name. Its name is title because that's what's coming in. I don't like the name string. And this to do comment, it put there by default. And you can, that's a clue that we're going to have to put some code there. You can make your own to do comments when there's stuff that you want to remember to do later. And then if I show view tasks, it'll show them all here. And when I click on them, it'll bring them up. Like if I was here and I clicked on that task, it would take me to that piece of code. So now when we look at our tests, that now compiles. And when we go down here, this is saying that we want to call the method getTitle on book1. And book1 is an instance of book. So we need a getTitle method in book. And you can see if you mouse over this, it gives you a couple of options for how you can fix this. I'm going to go ahead and let it create that method. But it's pretty stupid when it does that. GetTitle ought to return a string, but it doesn't know what to put there, so it just puts object. So if you do this, you should fix it so that it's returning a string. And get number of checkouts, I'm going to let it create that method. That should return an int. And if you don't know what something should return, the description in the book gives you the type for every one of these methods. And now that it's an int, our automatically generated return statement won't work. I'm going to make it return 0 because that seems like a good kind of default value for it to return. And then the last one is checked out. I'm going to let it create that. And this time it knows that it's Boolean because we were using assert false instead of assert equals. So at this point, I got everything to compile. I can right-click, run as JUnit test. I got to red. So it feels really weird, but at this point I would go woohoo, because I accomplished what I wanted to accomplish. Now I want to get it to green, and these to-dos are actually a really good strategy for how to get it to green. In order for getTitle to be able to return the catcher in the rye, we're going to need the constructor to remember that. So we said one of the things that the book needs to know is its title. So the book needs to know its title means it needs an instance variable that is a string that is its title. And I'm going to make the constructor store the title that was passed into that instance variable. Now remember, this goes back to scope. This is a local variable because it's a method parameter. Its scope is this part. I need to take that and store it into the instance variable whose scope is the whole class, and that way the object will remember it. So I use the keyword this to say I want the instance variable. When I use title without the keyword this, I get the local variable. And if you look, Java or Eclipse has tried to be very helpful. Instance variables are blue. Local variables are this kind of mousy brown color. So this will take what gets passed into the constructor and store it into the object that is a book. So having done that, I can rerun my tests. We still fail. And it says expected catcher in the rye, but was null. Well, I made it remember the title, but I never made it return it on the get title. So I'd like to fix this to do and make it return title. Oh, that's a weird way to spell title. Now I run my tests. Woohoo! So I got from red, now I got to green. Clearly, I still have these to-dos. So clearly I haven't built everything I need, but I did build everything I need to get this test to pass. There will be subsequent tests that will require me to build the parts that are these auto-generated stubs. So we did red, we did green, and then we do refactor. And refactor in this case is we're going to be missing a pile of the Java.comments. comments. And create a book. And I'm just going to do them for the ones that I have built because I'll fix the other ones later. This will return the title of this book. So that's my refactor stage. I rerun the tests to make sure I didn't break anything. I didn't break anything. That is one cycle through test-driven development. TDD is a process for writing code. Software engineers like it because it helps us think about what we're building before we build it, and because it helps us build our systems a little bit at a time, making sure that each part works before we move on. In the end, we have a full suite of tests verifying the behavior of the system. That gives us confidence to clean up the code and the ability to add new functionality without worrying if we've broken any existing features. Finally, the tests document the way we expect our classes to be used, which can be very helpful for our teammates. So, our TDD mantra is red, green, refactor. Red, write a test and watch it fail. Green, write the simplest code that can make the test pass. Refactor, clean up the code and make everything beautiful.